So I'm going to talk about Hanami and HTMX today. And these slides are power packed. I'm going to have them up available for you later so you can download everything. So I'm going to move pretty quickly here to keep you engaged, but feel free to stop me at any time, ask questions. I'll try to keep an eye out and stop the discussion there to dive in deeper if you need to. So with these frameworks or libraries is return to simplicity. And you might be asking, why is this important? Well, there's a couple problems. And one of the first problems is our software stack. So I'm going to pick on the JavaScript stack here a little bit. Not my favorite stack. But these are just kind of a mix of various frameworks, right, you can have on the front end. Then you can throw in Node. You got to deal with your package management, dependency management. Sometimes this can be several megs to a couple gigs, depending on how complex your stack is. You might have some post-processing here. I'm not being totally exhaustive here, but you might have some things you need to deal with as part of your build process. Then you've got package management that comes into this mix here. Got to shake the tree, compress everything down, and then get that deployed. And you might actually wrap that in like Docker or have a complex Kubernetes stack. Now, I'm not saying Docker is bad on itself, but once you mix in Kubernetes and really blow out this stack, it can get quite complex really quick. So I kind of want to burn this down a little bit. And I like this quote here, where when you look at the software industry and what's popular in this case, especially kind of picking on React, everybody wants to hire React developers. Everyone wants to go down that path, right? But if you kind of follow the money, right, these decisions and the reasons that we're building in that stack and hiring those kinds of engineers is not really because it's the right thing. It's just because it's the most popular. And I really like this quote to kind of like look at that and then take a right-hand turn. The other thing here is we've got Conway's nightmare. Now, as you might know, I'm going to put this simply. Conway's nightmare is basically based on Conway's law. And Conway's law is, in a nutshell, the organization of your team usually matches the organization or the architecture of your software. And on large clients that I work with, sometimes these teams get way out of whack, right? You got way too much management. You got DevOps, specialized designers, Scrum Masters for some reason have to be in this mix. And this gets really complex for things that we shouldn't have because it increases the communication that is necessary between the teams. So if you take this a step further, understanding Conway's law, where it becomes a nightmare is as this changes over iteration, right? You have one team structure, then the organization changes again. And when you kind of blur those all together, right, you have different versions of your teams and your architecture across that basically carries this baggage with you. And if you don't have time as engineers to basically slow down business and be able to clean up this nightmare, this baggage that you're carrying along the way, and clean it up each time you make an organizational change or an architectural change, this gets to be quite heavy. So what I like here, and I'm taking Henry Rollins' song lyric completely out of context here, but I think it fits with what I'm trying to say here in terms of being able to simplify and focus on just this stack and allow us to be full stack engineers again, right? Being able to think top to bottom, being able to think holistically without having to have complex communication channels. Thanks. So the ecosystem I want to talk about today is based on DryRB, which gives us the functional core. Now, as we all know as Rubyists, right, it's a very beautiful object-oriented language, but it actually has a very strong functional aspect to it. And DryRB allows us to enhance that capability. ROM gives us our persistence layer, and Hanami gives us the web framework, and HTMX gives us the Hypermedia REST front end. Now, I wish I could speak about all this. In fact, if I didn't have a time limit, I could basically talk your ear off all afternoon, or morning and afternoon. But I'm just going to focus on Hanami and HTMX today. So I'm going to give you a little bit of a teaser of a little demonstration application that I have here, and we're going to dive into it later as we go further into these talks. So you can see me clicking around on this demo application. I know the UI isn't super fancy, but I'm just focusing on functionality. And you'll notice that as I'm clicking around, I'm able to use keyboard events, mouse clicks, and so forth, and dynamically move around this application very quickly and be able to delete and update things accordingly. Now, that's all being done through HTMX, and I'm just making HTTP requests and getting Hypermedia REST response back. And I'm running this locally, so yes, it's very fast, and I don't have a lot of data in my database. So let's take a closer look at this. This time I want you to focus on the network tab, just to show you that there's no wizardry happening behind the curtain here. So as I click around on this app here again, notice all the requests that I'm making. I'm just using HTTP verbs here, right? I'm making patches, I'm making puts, I'm doing gets, and then I'm finally doing a delete here. Nothing special, but those are all HTMX requests being sent across the wire, but I'm not making any JavaScript calls here. It's just HTMX loaded as a library within the UI. Everything else is handled through the attributes on the HTMX DOM elements. So with that in mind, with that kind of setup here, let's dive into the Hanami framework so I can kind of give you a little bit of a structure as we move deeper into this. So a quick start is to basically grab Hanami, install it, and get it up and running, and that's great, but it's very primitive. So I've built a gem. You might have saw me walking around yesterday with my shirt for Hanami Smith, which is a gem that allows you to give you all the power tools you need to get up and running to basically get started doing professional development. The other thing is it sets you up with Overmind, which is basically Foreman on steroids. So it gives you a really nice development experience to get going. So kind of avoid the defaults there, maybe go with Hanami Smith to kind of build this out. And to explain this a little bit further, it gives you a nice CLI, Hanami Smith. And the main thing that you want to focus on is the build command. And with the build command, it actually gives you a bunch of options so you can tweak the way that you want to build your Hanami application. But it gets even better because it actually uses the XDG gem, another gem that I maintain, that allows you to have a global configuration as well as a local configuration. So if you don't want to mess with all these flags on the command line, you can store that in a configuration. You can rebuild your application or new applications using that same configuration. The other thing you'll be greeted with is a nice little splash page. So when you get this up and running, you'll see the Hanami Smith logo here, and then you'll have links to Hanami documentation along with some stats there. You can see what versions I'm running. So now that you've got that kind of premise, let's actually dig into the Hanami framework. Now there's a lot to cover here, and I'm going to have to kind of do the broad strokes. So in this, I want to talk about the structure, and some of this I'll leave for you to follow on your own time, but these are some of the power tools you're getting out of the box to kind of build this up so that you have things to get going really quickly. So I'm going to skip that, let you kind of dig into that on your own, but I want to focus on a few aspects of the application. And you'll notice in the structure here that this looks pretty similar to other frameworks that you've used, like Rails and so forth. The structure is roughly the same. Now in the app folder, there's going to be an action repository and view. And what this looks like is you'll define an action, and in Hanami, which you'll see here in just a moment, it allows you to define a single object. So the single responsibility principle that was talked about yesterday, you have a single object for every action that you're making. So basically it maps to the HTTP verb that you're making the request with. Then you're going to have your repository. So in this case, we're using ROM, and you'll see that I have a little bit of dependency injection happening here. I'm actually using a dependency container and then injecting a dependency that way. I'm going to break this down for you here in just a little bit. And then finally, you have the Hanami view. And with the Hanami view, this gives you the view layer. And I'll break this down for you in a moment here too. In the config, you've actually got your provider settings and routes. So what this looks like in the config, just kind of give you an example here, is here's a setting where I have my database URL, so I can talk to my database. And what that's doing is it's pulling from the environment, taking the database URL in the environment, and it's basically snake casing that and then type checking it. So we've got type checking built in. So not only does the database URL have to be present, but it has to be a string. Otherwise, there's going to be an error. So that's a really powerful feature that I've not seen elsewhere. And this is made possible through the dry types gem. In the routes, you'll see that I actually have a couple slices set up. We'll talk about slices here in just a little bit. But you'll see that I have a health slice, so you can check the health endpoint, and then you have the home, which is what that splash page was that you were seeing earlier. Also within here, you can have providers. This is a really powerful feature, which allows you to prepare, start, and stop the various providers that you have. They have life cycles. This gives Hanami the special ability to be able to cold boot rather quickly. And here's an example. So in this case, I'm using a Redis provider. And you'll see that I have a prepare step. This is pretty powerful in and of itself, this kind of cold boot that I was talking about, because if you don't need it, you don't actually have to require it. So you save yourself a bit of time there. In the start, then, you can actually register the client, initialize it, and then register it as Redis, the key there, which is put into the container that you can inject into your objects later. This is quite powerful, and I'll talk about this in a moment too. And then finally, you can stop. Now, I put this in yellow as a warning because you most likely don't want to tell your client to shut down the entire Redis server on shutdown. But I'm just trying to give you an example of what you could do. Maybe not exactly what you want to normally run, but this is just an example of what you could do in the stop cycle. And this is made possible or inherits from the dry system gem, for those of you in the dry community. So in terms of structure then, moving on here, we've got the database for your seeds and your persistence layer. Again, I don't have time to dive into this today, and in fact, the ROM is something that I'm still trying to get up to speed myself on. It's a different way to kind of look at how to deal with persistence. And then in the lib, you can have refinements, additional ROM type stuff, and types. This is going back to the dry types gem. Public right now with Hanami 2.0 does not have an asset layer, but it's coming quick. Hanami 2.1 is in beta 2 at the moment, I think, and so that's almost going to be out here shortly where you'll have a full asset pipeline. In this case, for the demo purposes, I'm just using rack static to just serve up static assets because I don't have anything sophisticated going on. Now, in the slices, I want to talk about this a bit because this kind of ties into what Mark was talking about yesterday with Packwork, but I think this is way more powerful without all the overhead and the YAML, and not to give you a hard time, Mark, but just to kind of focus on just pure slices, which basically encapsulates your business logic. Another analogy to make of this is, if you're familiar with like Rails engines, this is kind of in that same sphere, sort of, so to speak, but as anybody that's done Rails engines knows, testing those things is kind of a nightmare because you have to embed the entire Rails app in there to actually test your Rails engine. And with slices, you don't have any of that nonsense. In fact, slices allow you to have like mini Hanami apps, which you can later extract if you needed to into like microservices if you had to go that route. So here's an example of what this looks like. So that home splash page that I was showing you before, you'll notice that I have actions there. And again, one object per HTTP verb in this case. So that kind of flows through where you have your templates, your layout, and your show view. You have the view layer, which gives you the way to render your views that call out to your templates and layouts. And then you have action, repository, and view. Remember, I talked about those in the app folder. That's the global level. But at the slice level, you can define that and distill that down for just the business logic you need for the slice. So there's a nice way to kind of break these things apart. So the tasks that I showed you in the demo, as I click through the tasks, this is what this looks like a little bit more blown out. Again, you're seeing basically the same flow here, but I have an object for every action. And then I have some repository stuff so I can talk to my repository. Layouts and templates, again, just a little bit more blown out. Same thing with views, although with views in this case, I have some parts. The Hanami view layer not only gives us a view object, but you can then break those view objects apart into smaller parts, which then can be delegated to partials and templates and so forth. And then with the action view repository, again, I just have a way to tweak the way that this slice behaves versus my home slice versus the global slice, the global configuration. So with that in mind, let's talk about dependency injection just a little bit, because this is a pretty powerful feature of Hanami, and I want to emphasize this, especially coming back to the way that we brought in the persistence layer. And this is the D in solid design that we were talking about a little bit yesterday. Also, the single responsibility principle is at play here in the Hanami framework. So when we look at dependency injection here, here's what's happening. So the persistence layer that we're bringing in here, I'm basically trying to inject a container, my ROM container. And what it's going to do by default is it's going to take this key value pair, it's going to say persistence.rom, that's a namespace. It's going to rip off the prefix, that's how the injection happens here. It's going to bring it in as ROM, but I don't want it to be ROM. I actually want it to be container, that's why the key's there, so I'm renaming it so it's injected as container. So the way this is happening through the use of dry container. Dry container gives us the ability to have container so that we can define all our dependencies, and then later through auto inject, be able to inject those into our objects and pick and choose what we need from the container. There's a lot of flexibility and power here. And I'm not a huge fan of dry auto inject. There's one complaint that I have of it is that it injects your dependencies and it makes them public on your object by default. And like in some of the talks yesterday, the key thing here is to always make sure that your objects are locked down. You should only expose what you need. So again, I've developed a gem that basically has the same object API interface, and it's called Infusable, but it makes sure that that's private by default so that you have the option to expose what you need. To break this down a little bit further, just to kind of give you a contrast between the way Hanami does it and the way that the dry RB ecosystem works, is you'll have a container here, and in this case, I'm just registering an HTTP client and a logger. In this case, I'm using Cogger, which is a portmanteau of custom logger, another gem that I maintain, but it gives you custom logging capabilities. And I'm defining it here so that I can import this later, and in this case, I'm using Infusable. And I'm saying, hey, the import here, the terminology in dry-RB is import. In Hanami, it's deps, just short for dependencies. It doesn't really matter what it's named. It's just that I'm going to take this container and I'm going to say that's what I'm going to use for my import. Where this all glues together then is if I have this little demo object that I want to make a request to some URL, I can import. I can take my import and I can define what dependencies I want to bring in. So in this case, I'm bringing in HTTP and logger, but I don't have to bring in both. I could have just brought in the HTTP gem and just made my request that way and didn't log anything, or I could have just logged for some strange reason. But it gives you a way to define this once in a container, use this throughout your application all over the place, and then inject what you need within those objects. So moving on from Hanami then, taking a pause here and kind of switching gears and focusing on HTMX, let's talk about HTMX and then kind of tie all this together. So in order to understand this, we kind of need to go back and look a little backwards here and look at Tim Berners-Lee, who in 1990 developed HTML and Hypermedia. Then 10 years later, Roy Fielding came along and developed the representational state transfer REST protocol. And then finally, 20 years later, we have HTMX. Now, there's a 30-year time span of where we've been sitting on this technology and this birth of wisdom and knowledge, and we've kind of we've kind of gone far away, I think, from the original architects. Now, to be honest, HTMX isn't the first on the scene. In fact, Unpoly came onto the scene in 2014, and there might actually I know of a few other smaller projects, but these are kind of the main ones. But then you also have Phoenix Live View and you have Hotwire. Now, with Phoenix Live View, that's fine, but you're focused to the Elixir stack, right? You've got to be using Elixir, you got to be using Phoenix Live View, all that. You're tied to that stack. Same thing with Hotwire. Hotwire is fine, but you're tied to the Rails stack. And what I really like about Unpoly and HTMX is that it allows you to be decoupled from those stacks. You can write this technology, you can develop in this space, gain expertise in this, and be able to use it with any other stack. So there's portability built in. The other thing too, I just want to explain here as a little bit of a history lesson is I don't want to be remiss on being able to say that HTML isn't the only thing on the scene here. There's other specifications here, JSON LD being one of the bigger ones, that allows you to have JSON data, which actually has metadata to explain how to use it, how to self-describe it, right? It's not just raw data, structured data in JSON. It actually explains how to use itself. So you've got other ways to handle this too, but I'm focusing on HTML because the browser knows that and we got the built-in client, so we don't have to do any additional functionality there. So to kind of break this down then in terms of REST, Hypermedia REST is that with Hypermedia, with HTML, right, you already have self-describing language built in. Each of your tags explains what each thing's doing within the DOM here. And the various attributes that we apply to it, such as language being English in this case, and the hyperlink here being able to point to Wikipedia tells you what we're going to do, where we're going to go. So it's kind of nice describing language. And in this case, I'm going to make a GET request, an HTTP REST GET request to Wikipedia. So not to be super Captain Obvious here, but like if you render that, click on that, you get that web page back. We all know this pretty well. So if we walk through this a little bit more, I'm going to contrast this. So just again, simple web requests here. We're doing a GET, go to the HTTP server, we get that response back. Pretty simple. Where we've kind of lost our way here a little bit is that it's gotten complex. And what I mean by that is you've got the browser and you've got a data API that you're making, usually in these days, right, with a complex like React stack or whatever JavaScript stack you have on the front end. And in this case, like, I'm going to go ahead and create an article on Wikipedia. I'm going to post this article here. And this might come in as a request that is JSON. It doesn't have to be. It could be a form request. But there's a little bit of translation here, right? We have to take this JSON. We have to translate it. The server has to know how to translate it and actually to process that request. And there's communication between, if you have a front-end team and a back-end team, if any of this changes, right, they need to be in the loop. So assuming that that goes fine with the server, you send a 200 OK back with the JSON response, and then the browser doesn't know what to do with that. So you got to have something running in the browser, right, to translate that. Again, more communication between the teams and between the architecture of having to translate that JSON into rendering something within the browser. Again, I'm simplifying this greatly, but if you look at that JSON response that's coming back, a lot of people call this a RESTful API response. It's not. It's just a data API that's coming back. And the reason that is because even though this is structured data, I actually don't know what's going on here. I know that it's an article and it has an ID, but where's that? How's that ID supposed to be used? Is the, like the title in this case, is it supposed to be like the title of the HTML document? Is it supposed to be an H1 tag in the body? Is the body just a string every time? Does it have markup in there? Is there markdown supposed to be in there sometimes? Is there ASCII doc? The state is published, that's great, but how many other states are there? Like, I don't have any of this information. As a client, I actually have to know how to build this logic into my client application, the JavaScript on the front end there. I have to build all that in there. And so there's a lot of additional information that's just not there that you have with like Hypermedia REST, especially if you go back to what I was showing you with just the simple HTML. So taking a little bit deeper look here on HTMX, to get started with this, it's very simple. You could just pull in from a CDN just to get it up and running as a quick start. And the main thing is you're just using HX prefixes here in order to basically enable your DOM to be able to use the HTMX library. So in this case, where we have a button, what HTMX is going to do by default when you click on this, it's actually going to make that request, and the response it gets back is expecting to be HTML, and it's just going to replace that in the DOM. So pretending that we clicked on this, maybe we got like a little hello world paragraph that comes back, so it just replaces itself. That's the very out-of-the-box default behavior. So if we look at the Hemo application, another portmanteau, which is Hanami demo, smashed together as one word, we can go back to that demonstration that I was showing you earlier and kind of walk through this a little bit more by diving deeper into the source code here. So the first thing I'm just going to kind of prep you is I do have a demonstration application that you can download. You can clone this and take a look at this if you want to go through this in deeper. There's a lot in the application. And it's built with a git rebase workflow so that each commit adds to itself. So it's kind of like reading a book where one commit goes in, the next commit after it is like turning a page in the book. And that's kind of my gift to you so that as you look at this repository, right, you can kind of read and understand how it was architected. So you can dive deeper into this if you want to, if you enjoy this talk. So let's take a moment and actually dive into the source here just a little bit. We're not going to be able to go into all of it, but I'm going to touch upon some key things that I think would be very interesting for folks. Okay, so I'm going to start with HTTP delete. And you'll see here in the routes, I've defined just a delete action here. It takes an ID and then hits the delete endpoint. And it's going to hit the delete action here. So here's some code, and let's walk through this a little bit. So first off, you can see the dependency that's being injected. I'm injecting my task repository so that I can make CRUD operations to that repository. So I'm injecting my dependency here. Excuse me. I have a little bit of a refinement. The main thing I'm bringing in this refinement, just some custom code that I have in the app, is because I don't want to make I just want to condense some code because I have this situation where sometimes I have a body and a status, and I just want to define that once. So just a little bit of cleanup. Otherwise, it would be a couple lines of code to pull that off. The neat thing here is what you probably haven't seen before is the params. What this is using is it's allowing us to check the parameters coming in. So what it's saying is it must be an ID, it must be required, and it must be filled, and it must be of a type integer. And this is made possible through dry schema and dry validation. Dry validation is basically a superset of dry schema, but that's how this is being pulled off. And then finally, in the handle, that's the only public method that you really need to define on your action, is be able to handle the request and response. So in this case, I'm taking the request, I'm pulling out the parameters. If the parameters are not valid because of the validation that I did earlier there, I'm going to halt that request. Otherwise, everything's good. I'm going to go ahead and delete that and send a response back to the client. Next up, I'm going to deal with a partial. Now, this partial actually isn't specific to the, it's not a delete partial. It's really part of the index, because those index of tasks, I'm going to have a row for every one of those, or a row for every one of those tasks. And in there, I'm going to have a little button that you can do a delete. So in this case, just a simple delete action here, a post request, and has a little helper here, this delete button. So let's actually dive into that and take a look. So the helper here just defines the delete button. It's just a simple tag again. But the thing that's might be a little strange is I'm using an HTMX library. And again, another open source gem just to make this a little easier for everyone to enjoy working with Hanami and the HTMX that I developed, that basically just takes this syntax and allows you to write the HTMX attributes that you need without having to do the hx- prefix all the time. So what that really translates into is you have this code here, and you can see the hx target and the hx delete basically rendered for you. So that's just a little bit of nicety there. So when you take a look at this and you see that I click on the delete, you see the request that's made, and you see the response that comes back. There's that empty body. And when you clicked on it, it immediately deleted itself, replaced itself with the empty body of the response that came back. So fairly simple. So let's kind of spice this up a little bit and actually do a get. But let's add a little bit of search functionality to kind of expand what we can do here. So in our routes, we're going to go to the index action. And we're just going to render all those tasks. And then in this index action here, I'm going to do something a little different. So first off, you're going to notice that I'm injecting a dependency here when I'm bringing in the search view. And the reason I'm doing that is because by default, the view that Hanami already gives you by default, there's always a view per your action. It's always called view, and that's going to be your index view. But I also need to bring in the search view as a dependency that I'm going to inject. And so I'm calling it search view in this case. Then I'm going to check my params here, but notice that the params here query is optional, because if you load the index page and you force somebody to do a query every time, that's not a very good experience. So we want to make sure that that's optional, but if it is supplied, then it must be filled as a string. So we've got all our type safety checks going on. Then in the request and response handling here, we're going to pull out those params into a query object and then grab our task. Now, this design here is very simple. The task that I'm searching for when you query is just by description, so there's nothing too sophisticated going on. But I do have a little bit of a conditional here, and this is kind of neat because when the HTMX request comes in, it actually has a series of headers that's putting into the HTTP request for us. And what's really nice about this is I can look for that HTTPX trigger header. I can check to see if it's a search, and if so, I'm going to go ahead and render some HTMX headers back to the client so they can actually deal with updating the browser history. Otherwise, I'm just going to render the response, just the normal index view. That's it. Now, those HTMX headers, if we could dive into this a little bit further with this private method, I'm just going to set up the hx push URL, and I'm going to teach HTMX to say, hey, if the query is empty, I just want you to reset the URL in the browser to the root. Because if somebody's cleared their search query, I want to make sure that the URL in the browser is cleared as well, so that your browser history, you can go backwards and forwards, and that's nice and clean. I'll show you, we're going to walk into this a little bit further. Next up in the view then, I'm going to render all those tasks. And what's nice about Hanami, which I love as a breath of fresh air from Rails, is that with Rails, you have instance variables, and those damn things permeate all the way from the template down into the partials, and it can get yourself into a mess of trouble. With Hanami, you have to expose what you want to provide to your template. So you can have private methods, you could have additional dependencies injected into your view. That's not going to show up or even be accessible to your templates and your partials unless you expose them. And then next up, we have our template. So the associated template here is just going to render those tasks like I've been showing you in that table of tasks. And then we're going to have that search partial, or search template in this case, be brought in to render that search capability. So let's take a look at the search partial. So you'll notice here that I'm using some nice semantic HTML here. I've got my search, and I've got the form within. And what it's going to do is it's going to have a nice little search input helper. We'll get to this in just a moment. The other thing I'm going to do is I'm going to have a loader indicator. That's the spinner there as you're searching, and I'll show that off here in just a moment. And then HTMX actually comes with a few classes that use HTMX-prefix that allow you to show hide the indicator. Again, some niceties that the library is providing for us where we don't have to implement all ourselves. We're just able to actually add these classes on there and being able to show hide accordingly. And then finally, if for some reason JavaScript is turned off, we've got a nice graceful degradation here where you have just your normal search input and the clear link that will reset the form. So let's go take a look at the loader indicator and see how this works. So you'll notice in this demonstration here, I'm doing some searching, but because I don't have a lot of records in the database, and because I'm running in development locally, it's so fast that you don't actually see the indicator. So what we need to do is we need to kind of slow jam and slow this thing down a little bit. And what I mean by that is we'll just put a sleep in our action for 1 second and take a closer look at this. So here you can see that I'm searching, right? And with that sleep in there, you can see the indicator showing up, but it's showing in hiding because of that HTMX class I was showing you in the code there. So that's all happening through just this little bit of code here by defining the loader class and then adding that HTMX indicator class. So let's look at this search input a little bit closer too. So as you saw in the demo there, there's a lot of other things that were happening. And one of the things is I'm just doing a basic HTTP GET here to get the index, nothing too special there, but the trigger's cool. And the trigger that I was talking about in those HTTP headers I was showing you before, here's that search trigger that's coming in. Now, there's two ways I'm allowing this to happen. First is you can click physically on the search button and that kicks off the request. That's the first trigger. The second trigger though is when you're doing a key up. So if you're not even bothered to be mousing around and you just want to be keyboard full out, right? Not having to reach for the mouse, I'm just checking to see on key up and then adding a 200 millisecond delay so that I'm not hammering the server for every time you type something or make a screw up. I just wait a little bit, and then if it's changed, I send in the request. And the way this is done in HTMX is it's just a comma delimited set of commands here that you're defining. Next up, I'm teaching HTMX the target that I want to replace. So in this case, I don't want it to replace itself because that evaporates the search form. That would be bad. So what I'm looking for is just basic CSS, right? I'm just looking at the search form that was in the top of that page, that layout. And then down below is my table of tasks. So I want to look for the next collection of tasks, and I want those replaced with whatever comes back from the server based on your search. Finally, I'm doing the push URL, but this is push URL from the HTMX perspective, where I just tell it to be true. And what that does is HTMX says, when that's true, I'm going to go ahead and update the URL in your browser for your browser history. Each time you change something in the UI there, each time I get a different response back. So that's really nice, unless you overwrite it with the HTMX headers that I send back in the response that you saw in the action. And then finally, there's the indicator, which is the loader class that I was showing you. So that's just telling HTMX who to look for the indicator. So when you put all this together, you have a nice separation of concerns here. I really like how everything is nicely encapsulated and broken down, and nothing bleeds into itself. So there's a nice structure here that Hanami gives you. So if we take a look at this and you look at the different searching that I'm doing, notice that the history is being updated in the URL. So each time I type something different, HTMX is just handling that nicely for me. So again, to kind of, how am I doing on time here? To wrap this up, oh, okay, good. To kind of wrap this up in terms of simplicity, right, we have just using these two libraries, really distilling down the complexities that we have with teams with complex front ends, complex UIs. We have a way to actually still pull that off, but without so much technology. And being able to make just simple browser server requests here using Hypermedia REST. And it allows us to kind of get back to being full stack engineers again, without all the complexity, without all the communication channels, right? Being able to focus on what we do best as engineers. So if you need some additional resources on this, these are great places to check out. I highly recommend diving deeper into these communities, into these resources. I also talk about this a lot on my website as well. I write, teach, speak here all the time, so there's plenty of resources there as well. Also, just thanks for letting me speak here today and sharing this with you. And you can find me actually here on Alchemist, again, where I write, speak, and teach about this. I actually work as a consultant, usually with big companies, but also kind of bootstrapped, kind of entrepreneur type thing. So if you want to reach out and need any help in that regard, or if you're a developer entrepreneur trying to bootstrap your way and kind of break out into your own space, please reach out and connect as well. I'm really happy and trying to help in that regard. So thanks. If anybody has any questions, happy to dive in and answer as best I can. So.